Hey, hi everyone. So, welcome to the class of big data. We are going to start the class in some time. Just wait for it so that everyone can join. And even we are live on YouTube for today. Okay, hello everyone. How to do? Hello Jyoti. I know the YouTube link. Just for today, we are live on YouTube. Generally, we don't go live on YouTube. So, this is a very first class in a new year for a big data. So, that's the reason we thought of hosting it on YouTube. But yeah, tomorrow, so it is not going to be on YouTube. It is going to be in system itself. But yeah, you will be able to see our classes in YouTube as well as inside your dashboard. So fine, guys. Shall we start with the class? By the way, happy New Year to all of you who have joined this class in New Year. Okay, so let me share my screen. Sumit is saying Happy New Year, sir. Happy New Year, Sumit. MD, good afternoon. Good afternoon. Okay, fine. So let me share my screen and then we can start ahead with the class. So let me give you a small recap about a discussion that we had in my previous class, and then we can go ahead with the next class discussion. Okay. So, guys, agenda for today is in my previous class, I was talking about HDFS, I was talking about a name node, I was talking about a data node, and today I'm going to complete that architecture. So, most of the part from architecture side I have already discussed in my previous class. So, those who have not watched or those who have not gone through that particular class, so it's a humble request to all of you that please go ahead with a previous class because I have already discussed about the architecture. So here in my today's class, I'm going to complete that architecture and we are going to look into a setup of a data bricks. So we are going to set up a data bricks and if time allows and if you have everything ready, then we can try to go ahead with the Azure cloud account setup as well. Both. Aite is saying Happy New Year. Sumit is saying with your iron course, now I'm working as a data scientist. Hopefully, after completion of this course, I'll switch to a big data space. Sure, Sumit, and thank you so much. And yeah, I'm so happy to have you here again. Okay, so let's start talking about our architecture, guys. So, anyone who can tell me what we have discussed in my last class? Anyone? Yep. I just wanted to know like how many of you are able to remember. Okay, so five V's. Nagateja is saying five V's we have discussed. Yes, we discussed about five V's. Apart from that, yeah, five V's of big data. Sivani is saying five V's of big data. That's fine. And again, guys, those who have joined through YouTube, so basically we have made this live on YouTube just for today. We never go on YouTube, so it's a dashboard, so where people used to join, but just to spread the awareness about a big data class, just for today. So tomorrow, it's not going to be on YouTube. It's going to be on a in a dashboard. So even now, we are communicating over a dashboard. Sivan is saying we talked about HDFS, we talked about a master slave architecture intro. Ganesh is saying, okay, yes, that's true. We talked about a master slave architecture. We talked about a scaling out concept, I believe. Yep. Okay. Somebody is saying hi, sir. Halti is saying and name node, data node. Fine. So let's extend the same discussion. So today I'm going to conclude that particular discussion, which I have started in my last class. And we are going to see a setup of a data bricks, because from tomorrow onwards, we are not going ahead with the theoretical concept. We are going ahead with the practical concept. So we will start our Spark journey with a Databricks, where we are going to write a code. We are going to do a lot of experimentation with data files. We are going to understand how Spark works internally, how I will be able to build a ETL pipeline. Then we are going to discuss about Azure Databricks. And then going forward, obviously, Azure Data Factory, we are going to talk about SD Inside, we are going to talk about. There are so many services across a cloud. That is something that we are going to discuss from tomorrow onwards. Today is my last day for our architecture discussion. So, okay, let's start with HDFS architecture, guys. So, HDFS, okay, let me write it down in a proper manner. HDFS, Hadoop Distributed File System, and this is what we have discussed. And just to give you a brief recap, not in depth. So we were talking about basically a concept of a name node, basically, and then we were talking about a concept of a multiple data node on a commodity hardware. And we have even seen a master slave architecture, which has been derived from the same thing. So where there is a name node and then there is a data node. So all of these things are nothing but a data node, data node, where actual data resides, and data node 1, maybe 2, maybe 3, maybe 4, maybe 5. Yeah. So where your actual compute happens, where your actual data will reside, where actual read, write, and whatever operations you are going to perform is going to happen. And name node will more like behave like a director. So it is going to ask a data node to store a data. Again, we talked about a replica as well, that whenever system will try to store some of the file, whenever system will try to store some of the file, so obviously it is going to replicate, it is going to create so many replicas, or not so many replicas, I would say, depends upon my like a replication factor. So I'm assuming as of now 3, which is a standard one as per the industry. So it is going to replicate all of those data set into a different data node. And we have even seen a mechanism for replicating data, right, everyone? Yeah. So we already seen these things. Before learning PySpark, is it required to learn Hadoop? No, you're just supposed to be like aware about a Hadoop architecture. Then inside that, there is nothing to learn about Hadoop. Actually, there is some sort of a command which is technically a Linux kind of a command with a flavor of Hadoop that you are supposed to be aware about. So all of these things comes inside the practical one. So Spark can runs on top of the Hadoop, Spark can runs on a standalone mode, and many more things. So all those things we are going to explore over there. Okay, fine. So now let's get started. So this is something that we have already discussed about, and we talked about a rake architecture as well. Now let's try to understand that how name node keep itself updated, because name node is going to be one of the busiest node, because it is managing each and everything, and whatever new operation you are going to perform, so everything will first go ahead with the name node, and based on the name node availability, it is going to perform all the operations inside all of these data node. So in today's class, we are going to talk about one of the interesting file system which exists inside a name node, and that is called as FS image. And full form of that FS image is basically a file system image. So how file system, I think I have already given you a brief intro about the file system image in my previous class. So I'm just trying to extend the same lecture. And why we are going to use a file system images, what will happen if file system image itself is going to be corrupt, where file system image is been created, what is a meaning of a edit log, all of these things we are going to discuss. So in previous class in my architecture, so we talked about that name node will try to perform every operations in a very first place. So basically it's going to work like a manager over here, and it is going to manage the entire data node, and it will be having an idea, that what is going inside which data node, what kind of a file I have written inside which data node, what where and all we have a replica inside all of these data nodes. So name node will be having a idea about each and everything. Now, as I mentioned, that name node is one of the busiest node. So whenever, and the power, the superpower of name node comes from basically, so superpower of name node basically comes from FS image. So you can say that FS image is nothing but it's a brain for a name node at any point of a time. Whatever operation name node will be able to perform, it will be able to perform based on this FS image, because it is going to hold all the metadata, all the information about each and everything which has happened in a past. So here, if name node is one of the busiest one, then how it will keep on updating itself on a regular basis, how it will be able to perform all of these tasks in a fastest possible way, because there is a situation that may arise where name node will be choked completely and it will not be able to perform any operations if it is keep on updating itself and keep on sending directions or operations to the subsequent data node. So here there is something called as a file system images, FS images. And like I said, so this is called as file system image. Now it's a brain for, or you can say it's a place where name node will be able to hold each and every data set. So let's suppose if I'm updating some of the data node, so obviously that update should get reflected inside a file system images. If that updates are not available inside a file system image, name node will not be able to perform any kind of operations going forward. And again, there will be a problem. So if name node will not be able to keep itself updated, so how file system updates itself, this is something that we are going to discuss. So there are two major component image. So there are two major component you will be able to find out. One is a file system image and one is a edit log basically. So one is basically a file system image and the second one is basically a edit log. Now where this edit log comes into a picture, so like we were talking about a file system images and immediately we have started talking about a edit log. So what is this particular edit log and how it is going to work, how it is going to behave? So see guys, what happens is, and again in an interview people are going to ask you this question on a concept called as check pointing. Now, what is this checkpointing? So here, what happens is that whenever you are going to update any kind of a record inside a data node, whenever you are going to create any replica inside any of the data node for any kind of a data set, whenever you are going to break down your data set into a small chunk, so each and every operation should come back to name node and it should update a name node saying that yes, I'm able to perform this operation. And even if something is going to fail, it should come back and say that okay, maybe I'm not able to perform this part of the operations. Simple. Now the helper one over here for a name node is, or the main file meta file for a name node is basically a file system image. With the help of file system image, name node will be aware about each and everything. But the problem is name node is one of the busiest nodes. So for every second, for every small processes, it will not be able to update itself. Now, keeping that in a mind, this checkpointing comes into a picture. So concept of checkpointing says that let's suppose there is a primary node. I'm assuming it's a name node, and there will be another node, you can say, and which is called as a secondary node. So there will be a primary name node, let's suppose, and there is a secondary name node. So there will be two nodes, let's suppose. Now here I have a, so let's suppose I have started a system just now. At time t is equal to 0, I'm starting a system for the very first time, and there is a primary name node. P means primary, S means secondary. So here at time t0, for now, if I'm starting a system and if I'll start processing a data, if I'll start maybe reading or writing a data, or maybe creating a replicas inside my entire data node or cluster, right? So there will be at time t0, you will be able to find out fs image 0th. Fs image 0th. As of now, I have just started the system for the very first time. Now what I will do is that I will keep on updating my data node. I'll keep on updating my data node, and system will keep on generating a logs for it, metadata for it, that I'm doing this, I'm doing that. So system will keep on doing this process continuously. So it's not like that it is going to update this file system immediately. No, what it will do is, so there is another separate node, so that it can keep my primary name node free, as much available as possible, because this is where the speed will come into a picture inside your entire cluster. If your name node itself is completely occupied, then obviously you will not be able to like get the speed that you are looking for. You will not be able to achieve the latency that you are looking for. So here what will happen is that there will be secondary name node. Secondary name node will try to create something called as edit log, and with a timestamp. So till time t0, our primary name node is aware about it, that what has happened between time t0 or till time t0. Now from time t1 till, let's suppose, time t10, right, for this fraction of second, whatever operation which will happens inside your cluster, so it will try to store inside your edit log, and that too inside a secondary name node, not inside the primary name node. Now still, let's suppose whatever has happened in between this time t is equal to 1 till time t10, now name node is not aware about it, and obviously everyone is going to ask name node to perform some of the operations. So whatever incoming request will come, so name node is supposed to receive that incoming request, and name node is not aware about this phenomena, this event basically. So whatever event has happened between time t is equals to 1 till time t is equals to 10, name node is not at all aware about it, unless and until I'm not sending this file, I'm not sending this file back to my primary name node. It will not be aware about it at all. So how we are sending this particular file? So what happens is that inside a secondary name node, we try to make a configuration. We try to make a configuration that, okay, so try to create a edit log over here. Edit log is again one of the file. So between this time t is equal to 1, line t is equals to 10, and whatever fs image, file system image, is available previously over here, let's try to bring that file system image even in this particular place, and in a regular interval, on a regular interval, just do one thing. So try to merge based on the rule, so based on the rule that we are going to define, so maybe based on the size of the file and based on the time. So based on the rule that we are going to write, that okay, so just try to store a 10-second of data, maybe just try to store a 20-second of data inside a edit log, and when it is going to complete this 20-second, do one thing. So try to append, try to append what? So try to merge these two files, try to append these two files, the file system image till 0, right, the file system image till 0th time, and this edit log from 1 to 10. So what system will do? So it is going to merge both of this file. It is going to merge fs image till 0 plus edit log 1 to 10. It is going to merge it, and then it is going to create a new fs image till time second 10, till time second 10. So it is going to generate a new file system image for me. Now this file system image is available inside a secondary node. Now, still, if it is going to get some sort of a request and about a task which has happened between 1 to 10, name node will not be able to respond, because name node is having literally no idea, no clue that what has happened between time t is equals to 1 till time t is equals to 10. It is not having any idea. So where we have stored the file, what kind of a replica that we are able to create, which process has been submitted, which process is running inside which data node, it is not having any idea whatever has happened between 1 to 10, because secondary name node will be having an idea, but name node is the primary one which is going to respond, not a secondary one. And this phenomena, this particular process where we are merging file system image and our edit log, so where we are merging this file system image and our edit log, so this particular phenomena is called as what? It's called as checkpointing. I believe my screen is visible, right, to everyone? Yes, if you can respond in a chat. Yeah, dashboard chat. So here it is going to perform a checkpointing. So this phenomena, so where we are going to merge file system image till a particular timestamp with a edit log till a certain timestamp. So this is called as checkpointing. So now after this checkpointing, right, after this checkpointing till 10th second, it will be able to create a new file system image. So obviously, this file system image must be available with a primary name node. Otherwise, primary name node will not be able to respond to a query. So once this will be available, secondary name node is going to send a ping to my primary name node, saying that whenever you are available, so it is going to send one signal over here to a primary name node, saying that whenever you are available, allow me to send you the next file system image. So if name node is busy, so it will keep on waiting, it will keep on pinging to a primary name node. And once name node will be available, once it will be able to receive a ping back saying that yes, I'm available, what it does is, so it is going to send this data, it is going to send this fs image, file system image, to a primary name node. And now primary name node will be having a updated file system image till 10th second, and now it will be able to respond. So this is how primary name node will keep on updating itself at any cost. Yes, Navneet is saying not understanding the concept. Navneet, have you joined the previous class? Because this is just an extension of the previous class, Navneet. So where I talked about a name node, I talked about a data node, I talked about like a replica concept, I talked about rakes over there, I talked about a concept where how a file will be broken down into a chunks and then it will be stored across a different data node. So it is just an extension of the same class that I have like started in like 2024 December. Okay, so fine. So now name node will be having, primary name node will be having an idea that okay, so we have a new fs image and it will start responding to each and every queries, and whatever like a submission it will be able to get with the help of this file system image. So and this process of merging your file system image plus edit log, right? So process of merging file system image and a edit log is called as checkpointing, and many people are going to ask you this question even inside an interview, that what do you understand by a checkpointing? Okay, so it's your first class. So I'll request you to please go ahead with the previous classes and just wait inside this class for some time, I would say, because anyhow we are going to close this entire architecture discussion and we are going to move into a practical part. Tomorrow, like today, we are going to like do a setup more or less we are going to do a system setup, so where we are going to do a coding and everything. So again, from tomorrow you will be able to pick each and everything. Okay, fine. So this is how checkpointing is going to happen. So hope all of you are able to understand. So any question, guys, for me? Ping me in a chat, please. Got it. CC. Okay, fine. So hope we all are able to understand this particular concept. Now, so moving ahead. Okay, why is this important? Umar is asking why is this important. So this checkpointing one, because unless and until you are not going to perform a checkpointing, how name node will be aware about a new development? So let's suppose something you have performed inside your system between 1 to 10 second, and that one is getting logged, getting tracked into secondary name node, not into a primary name node. But primary name node responds to all the queries, right? So unless and until you are not going to perform a checkpointing, unless and until you are not going to merge a file till a particular timestamp together, and you are not going to send that particular file to a primary name node, system will not be able to aware about a new development at all, and in that case it will not be able to respond back. Your queries are going to fail, and this is the reason it is important. Checkpointing is important. Now you maybe ask me a question that why we are not doing a checkpointing inside a primary name node. See, primary name node serves all the queries, so it's one of the busiest node you will be able to find out inside your entire cluster. It is taking care of not just one process, it is taking care of the entire cluster. So if, and this is the continuous process, this log generation is a continuous process, because for even a small task, or there are so many background processes, so even for the smallest of a small task, it is going to generate a log. If it will keep on writing that log inside your name node will be slow, which we can't afford, because we are trying to build architecture, we are trying to build a system which must be able to process a huge amount of data with a very very low latency. And in that situation, obviously your name node is supposed to be available all the time to solve the query. Fine, everyone. So just do a 5 second of revise for up to this time. Sumit, I have, I think, already revised. Amit, sir, can you connect with everything with the whole architecture? Okay, okay. So whole architecture. This is your primary name node, by the way, and this is what I'm talking about. And if you remember, so last time I have drawn another architecture. So where we are trying to, so where we have created a rake kind of architecture to store a data into a different zone. So this is the architecture that I have discussed, where we have, let's suppose, a rake number 1, we have rake number 2, and we have rake number 3. We have a data node over here, multiple data node into one rake, multiple data node inside a rake, and there will be a name node. Name node is going to receive some sort of a query to store a file. Let's suppose this is my file, so it is going to break down into a chunks, and it is going to ping. So let's suppose this is a rake 1 data node 1, rake 2 data node 2, rake 3 data node 3, rake 4 data node 4, then rake 2 data node 1, rake 2 data node 2, rake 3 data node 3, rake 4 data node 4, and then rake 3 data node 1, rake 3 data node 2, rake 3 data node 3, and rake 3 data node 4. So it is going to send this particular chunk of the data to one of the node to store the information. Maybe this is the file, maybe like a 64 KB of file I'm trying to store. So it is going to ping to everyone, whichever is going to respond back immediately. So it is going to hold that data, and then it is a responsibility of a next data node to store a replica. So replica 1 will be stored over here, replica 2 will be stored over here, and maybe replica 3 will be stored over here. Now once a replica will be stored, so it is going to ping back saying that I'm able to store the replica. It is going to ping back saying that I'm able to store the replica. Now obviously till this point of a time it has already generated a lot of logs. So now that log will be stored where? So that log will be stored inside a secondary name node. Simple. And now inside secondary name node, what will happens? So inside secondary name node, this will happen. Making sense? I think I'm able to connect each and everything. So from where secondary name node comes into a picture. So whenever I'm storing a file, right? So I'm trying to create a replica into a different region, or maybe into a different rakes, into a different data rake, or like a data node. Now, once it will be able to do the entire process, so obviously it is supposed to give a feedback saying that yes, I'm able to create a three different replica, three different copy of the same file, and now this is the place, this is the location, this is the chunk of the file which I am storing in this particular data node. So all of that information will go where? It will go inside the secondary name node, and it is going to hold everything inside a edit log between 1 second to 10 second, let's suppose, and then so on, obviously. So let's suppose in every 10 second, every 20 second, as per my configuration, so it is going to checkpoint it. So it is going to like hold each and every information, whatever has happened in between this particular timestamp inside the edit log. It is going to merge with the existing file system image. So let's suppose name node is having an idea till timestamp 0. So it is going to merge with that. Now this process is basically called as, so let me remove this part. Yeah. So this process, the checkpointing, this checkpointing process is going to happen into a secondary name node. Secondary name node is going to ping back to the name node saying that I have a new fs image till time 10, basically. So till 10 seconds, so I have a fs image, a new metadata available to me, and it is going to send that metadata to a name node. Now name node will be able to update itself, so it is going to delete the old one, and it will be having a new fs image, which is an actual brain for a name node. Now name node will be able to access this fs image, and based on this access image, this fs image, it is going to reply back to all of your query. Fine? Making sense? So how data will be stored? I believe I have already discussed about these things in a very detailed manner in my previous class. So yeah, this is the new addition. So secondary name node and a new name node, primary name node. Okay, so Jyoti is asking what happens if secondary name node is unavailable. Okay, so if secondary name node will be unavailable, so we'll be having a backup node as well. Plus, whenever we are going to create a fs image, we always try to even take a multiple replica of that fs image file as well. So even if one node is going down, because that's a whole idea behind the in this architecture, right? That whatever file that is available to you, just do one thing. So try to store a replica, try to hold a replica of each and everything. Doesn't matter if my secondary name node is going down, it's completely fine. Once it will come back, once my system will come back, so I will try to retrieve a file, the last checkpointed file from my replica, and I will be able to start my entire cluster from that particular point. And again, so we try to set up a multiple backup nodes as well. So wherever we are working on a project, which should be available 24 by 7 without any downtime or 99.9% of uptime. So in that situation, we always make sure that we have everything inside, or we have a backup node configured inside like our entire cluster. Okay, so now moving ahead. So here, this architecture is completely fine, and more or less we are able to understand this entire architecture in this two discussion. Now the next part is where we are going to practice the entire, so where we are going to practice the entire big data, and what and all tools and components are required, right? What and all tools and components are required. So this big data class is designed based on the entire cloud platform. So we are not going to do anything, or maybe going forward, one or two like stuff we are going to do in our local system, but anything and everything we are going to perform over a cloud based platform, or we are going to use a tool which is available over a cloud, because this is what our industry trend is. So one of the first tool that you are supposed to access is called as Databricks. So just go to a Google and try to search for a Databricks, guys. Everyone. So just go to a Google, try to search for a Databricks, and over here, so not a Databricks Lakehouse, so databricks.com. Yeah. So just go to a database.com. So you will be able to see this particular page. Let me ping you this link inside your classroom chat box as well. So yeah, so this is the place where you have to go and click on try Databricks and try to log in. Login steps are very simple. You have to select for this option, get started for free. And yes, so you will be able to access most of the services just for free. Obviously, I'm going to explain you that for some of the services, maybe you will have to pay and you can avoid it. If you don't want to do it, it's completely fine. But inside your class, I'm going to show you free, paid, every kind of a services. So I have a free account, I have a paid account, I have both kind of account, and it's my responsibility at the end of the day to show you free and paid, both the version, and like every kind of a things over there. So here I can just try to click on get started for free and then continue to express setup. Don't look for the cloud based setup, and then just sign in with the Google account. Simple. Continue, and then maybe you can try to select your country, India, then continue. And yeah, so you can try to solve the puzzle like the way I'm solving it. Verification completed. Fine. Setting up an account. Okay. So are you able to do it, guys, along with me? Just say yes or no in chat. Yep. Pradeep is saying yes. Okay. Okay, so once you are going to log in into your Databricks account, so are you able to see a same interface, guys, or are you able to experience a different kind of an interface? Yep. Are you able to see the same kind of a interface? Is that same, everyone? Done? Setup? It's very easy actually. Believe me, guys, it's very easy. It's nothing like just log in. It's easier than logging into a Facebook because even Facebook is having a lot of verification and checkpointings and all those things. But yeah, logging into a Databricks account is not at all a big deal. And I believe all of you are able to see a exact same kind of interface. So let me give you a detailed demo, a very detailed demo about this entire interface that you are able to see on your screen. So as of now, you don't have to add your credit card at all, right? So you don't have to worry about your credit card adding anything over here. So this is a Databricks homepage, and you will be able to see multiple things. You will be able to see this new tab, workplace tab, recent, catalog, workflow, compute. Some of these tab will be available to you. So once you are going to click, you will be able to access it. Some of these tab you will not be able to access because Databricks is not allowing you to like use it in a free mode. You have to like go ahead with the paid mode. And this Databricks, a same Databricks, you will be able to find out even inside Azure cloud platform. So Azure cloud platform try to provide you a dedicated Databricks, which is called as Azure Databricks, where you will be able to configure your own compute. You will be able to schedule a job. You will be able to create a complete ETL, extract, transform, load kind of a pipeline in a easiest possible way. But here, first of all, we have to run a lot of Spark job. Now, to run a Spark job, we don't need much of compute. So whatever compute Databricks is giving you by default, you will be able to utilize it and you will be able to perform each and every kind of operation, believe me. Now here, so let's click on new. So once you are going to click on new, you will be able to find out a very first option called as notebook. So just click on notebook. Yeah, just click on notebook. And so once you are going to click on notebook over here, so it is going to give you this kind of an interface. You can come over here, you can maybe change a name if you want. So test notebook, uh, like a V1 I have named it. So whatever you like, you can just name it. Now here, if you are going to click on this Python, you will be able to find out a multiple options. You will be able to find out that by default it is going to execute a Python query, but it is having a SQL capability, it is having a Scala capability, it is having a R capability, and Markdown. Markdown is nothing but documentation basically, right? So documentation you will be able to do. Python is by default. So let's suppose if I'm going to write maybe some sort of a, like a print over here. So print, this is my first code in data bricks. Okay, this is my first code into a data bricks. Now if I'm going to execute it, yeah, if I'm going to execute it, now to execute anything inside a data bricks, I have to attach a compute. Unless and until I'm not going to attach a compute, I will not be able to execute anything. Compute means obviously like a, I need a RAM, I need a main memory, and I need a CPU or GPU, whatever, right? I can get anything. But yeah, in a free, not in a free mode, but yeah, in a paid mode, I can get anything. So here you will be able to find out a compute tab. Just go and click on this compute tab, guys. Just click on compute tab. Okay, I think I have already created a default compute. Let me check. Okay, so fine. Just go on a compute tab and serverless starter browser. I think I have been using this account in which I have logged in. Okay, not an issue. It's fine. Yeah. Or you can even click over here. So this is like a button. This is the dot, right? So you can even click over here. And then you can try to select the serverless and you can try to execute it and block the notification. And it is trying to spin up my serverless compute, which is nothing but a shared one. Test v2 environment version 2 is available. Release note to learn. No, I don't want. So yeah, just wait for some time and yes, it is able to execute it. So this is my first code in a Databricks. Now here, I will be able to do each and everything. I will be able to write a code, and by default, Spark will be available inside a Databricks by default. So you don't have to even worry about setting up a Spark into a local system, although you can do it, but it's a very, very tedious approach. And again, depends upon system to system. So you will face a lot of configuration issue. So it's better to write all of these things inside a Databricks and then productionize it with respect to a cloud, because everyone, even inside the industry, they are doing the exact same thing. So the way we are going to execute our Spark code in the exact similar manner, people even inside the industry, so they are doing the things. So are you able to execute a first line of code, guys? Yes, it's very easy. Just like writing a Python code inside a Google Colab or maybe inside your VS Code in the exact similar manner. So you will be able to write all of these things even inside a Databricks. So here is a notebook. So where you are going to spend most of your time. Most of means for next couple of weeks. So when we will be learning a Spark, when we will be learning a Spark ML, when we will be learning a Spark SQL. So most of the time you are going to spend over here. And then after this phase, most of the time you are going to spend on Azure. So with Azure SD inside Azure Data Factory, so most of the time, and Azure related services, you are going to spend most of your time. Okay, so here is a notebook and I can select. So if I have to execute a SQL query, I can try to execute a SQL query. If I want, again with respect to a data, I'll be talking about it, that how you can try to upload a data, how you can fire a SQL query in a step by step manner, how you are going to write a Spark code, each and everything. And anyone inside this class, guys, who is not aware about the Jupyter notebook, if you're not aware about Jupyter notebook, maybe I can give you the explanation. I believe Jupyter Notebook is a very common one, and those who have gone through the Python classes, so they're already aware about it. But if, in case, if you are not aware about it, do let me know. I'll give you a complete walkthrough. Just Jupyter Notebook, not other services. Others, I'll come back to other services. By the way, yes. Okay, Amit is saying learn from you only, sir. Yeah, then it's fine. So now you're aware about it. Okay, so we are not supposed to discuss about a Jupyter notebook. It's just a simple file. So where you can go, you can create a new notebook. If you have to export it, so you can try to export it as a DBC archive. DBC is nothing but basically a Databricks file. So if you're going to download it as a DBC archive, in that case, you can directly upload it, and whatever is available in your system, it will be able to replicate the exact same thing. Even you can try to download it as a export it as a IPNB Jupyter notebook. You can download it as a source file, whatever you want. So most of the time I will be sharing these files with you in every classes. So after end of the every class, so obviously I'll write a code inside a class, and I'll end up sharing either of these files with all of you. And here you're going to spend most of the time. Now going forward, I'm going to teach you that as of now you are running this entire program on a serverless. Basically, serverless means whatever Databricks has given to you, you are running each and everything on that particular compute. Now, I'm going to teach you that how you will be able to create your own server inside an Azure, how you are going to use that particular compute inside a Databricks. But yeah, that will come into a picture in a later stage. Now, another thing I would like to highlight. So just go to setting, guys. Go to setting and go to advanced. I think they have changed a couple of things over here. In last 2 3 days, they have changed something, I believe. Mm. Notification, no. Workspace access, this is fine. This is enabled. So permanently pause a workspace storage, that's completely fine. This is fine. This is fine. External integration is on, so this is also fine. Help center, user analytics, other. Okay, so partner power AI instant feature, that's fine. Database auto logging is fine. Yeah, so all of these setting looks fine to me. Mm. SQL warehouse, identity and access, no, I don't want. Appearance, fine. Date time, okay. Fine. So this setting looks fine to me. Previously, I used to change one setting for a data upload, but now I think it's not required. They have given you by default, and there is a changes which I'm able to observe inside this entire interface. A little bit of changes, you can say. Okay. So there is a workspace. So here it's nothing but just like your directory. So the way we create a directory inside our local system, so whether you are using a Mac, whether you are using a Unix Linux machine, or whether you are using a Windows machine, so in the similar manner you can come over here and inside your user tab, so inside your own user tab, you will be able to create your workspace. So you can go over here, you can try to create a folder, you can try to create a notebook, you can try to create whatever you want at any point of a time. So the file which I have created so far, so basically this file is available inside my workspace, and at any point of a time, if you have to find that file, simple, workspace, and then come to user and come to your username. So whatever username that you have given, so this is my code commander 42 at the rate gmail.com. For you, you must be having your own username. And here, so maybe just to create a structure, I can try to create data bricks experiment folder. So I can try to create it over here. Then inside that, if I want to create maybe a notebook, so I can just go over here and I can try to create it. And again, if I'll come back, I will be able to find out everything inside the Databricks experiment. So here you will be able to maintain a proper directory structure the way you used to maintain inside your local system. So again, this is very, very useful, where you can do each and everything. Recent means, again, I believe you all are able to understand. So whatever recently you have done, so it is going to show you that part. Now catalog is nothing but it's a data. So this is where you will be able to upload your SQL data. You will be able to see some of the default data as well. So here, this is a catalog, and inside that, again, we are going to do a lot of operation. As of now, there is no data, so we are going to do a lot of operation inside a catalog by uploading a different kind of a data. Now workflow. So previously in a free mode, they have not given us a workflow, but now they are giving you even a workflow feature for a experimentation purpose. And I believe this feature they have enabled in last 1 week. Otherwise, I was using my paid account to create a workflow. Now compute means, so you can try to like create a compute. You can try to create a compute directly from here, or you can try to attach any external resource as well, from AWS, from Azure, or from GCP, or from Azure Databricks. You can launch even a Databricks. Okay. Now there is something called as dedicated SQL editor they have given to you. So whenever you have to practice or experiment any kind of a SQL query, you can come over here and then you can try to execute all of these SQL command, and bingo, it will be done. So even SQL you will be able to practice inside a Databricks itself. Now queries, so create my queries, and here, so you will be able to like schedule any kind of a queries that you are looking for to fire into a data bricks. Then Jenny is nothing but their AI system they have created, and this is basically a AI system that they have created, AIBI Jenny. And again, so I have never used it, basically this one. So I have my own account over like all the AI systems. So barely I use this Jenny over here, and actually I have never used this particular Jenny. But yeah, this is just a AI feature, just like anyone else is offering you a AI feature over a different kind of a platform. Now there is something called as a SQL warehouse. So for dump of the data, you can try to create a SQL warehouse, but I believe it is going to cost you. Yeah, it is going to cost you. So upgrade your account to create a large warehouse. So just avoid this one. Basic query, anyhow, based on the small data set, you will be able to execute, but this is going to give you a cost. Okay. So Umar is asking, database available on GCP. Yeah, you can integrate with all three, like GCP, AWS, and Azure. You can use a compute from anywhere. You can use other integrated services from anywhere. Now there is a platform called as job run or workflow platform. So here what we are going to do is, so we are going to create a multiple different kind of a job, or a series of the job, where one is going to run after the another based on the rule that we are going to set, and we are going to schedule all of this job inside this particular section. This is just an overview. We are not doing anything as of now. Now add data. So you will be able to add a data from a local, and you will be able to add a data from all the possible platform that you know. So they have given you not just one or two option, they have given you a lot of option, right? They have given you basically a lot of option inside this one. So add data, and even you will be able to upload a data from your local, and that is a feature that we are going to use. So we are going to upload a data from a local first, means from my local drive. Same data I'm going to share with you inside the class, and we are going to work on that data first, and then obviously it's all about the connectivity. So wherever you have a data, they have already given you a plugins. You will be able to pull the data and you can run the experiments on top of it. Now for a machine learning, they have given you a playground. So nowadays LLMs are like getting very much popular, and they have given you LLMs over here. So Metalama 3.370 billion, 405 billion, DBRX, Mistral, all of these is available, but in a paid mode. Simple. So this is not at all free. We are not going to use this ML feature or playground feature at all, because we will be focusing more on a big data job, not on a machine learning based job. But yeah, so this is the recent feature that Databricks has introduced, and that too in a free mode. So where you all will be able to access this machine learning playground and experimentation just for free. So here you can create a complete automated pipeline in a easiest possible way, in a plug and play way, and it is going to perform each and every operation. So this is of no use. Machine learning I'm not going to discuss in general, right? Okay. So this is just an overview, guys, about the entire platform. And like I said, I'll be using mostly a notebook in a beginning from this one. Why I'm going to use a notebook in a beginning? Because I don't want to install, I don't want to configure a Spark inside my local system. Because if I'll if I'm talking about a Spark, I have to run a Spark job, a Spark SQL job, and maybe a Spark streaming job I have to create, maybe a Spark MLlib job I'll have to create, and it creates a lot of dependency in our local system. Now, keeping that in mind, no local installation, no hustle is required, and entire industry is using Databricks. So we are going to use Databricks. I believe I have made myself clear. Yes. Okay, now next part. Anyone who is having a Azure account, by the way? Anyone is having Azure account, guys? Okay, so Pradeep Tutu is saying, yeah, Pradeep, yes, Joy, no, sir, Radha Mohan, yes, Ganesh, yes, Pradeep, I have, Amit, yes, a free one. Okay, fine. So anyone is fine, right? So I have a free account, I have a paid account. So I have like basically both the accounts. So we always try to keep multiple accounts, because we have to create a content and we have to do a lot of experiments, right? So I'm going to show you that Azure Databricks you will be able to launch even from here. So if you will come to the those who is not having Azure account, guys, please go and try to create a Azure free account. Even Azure provides you Azure students account. So you can maybe go to Google and then try to search Azure students, students students account. But I'll never recommend to use the student account to build a professional grade project, because some of the feature they are giving you a credit, that's completely fine, but some of the feature which is required to build a professional project is not available inside a free account, especially inside the student account. Yeah. And just try to use a free account, never try to use a student account. Well, you're not a student, right? So you're uh, basically preparing for your next job. So obviously you have to like a get an account where all the features are enabled, at least maybe going forward. So you can try to like pay for some of the feature and then you can try to avail it, depends. But yeah, so those who is not having a Azure account, so please go ahead, create a Azure account. We are going to use a Azure account heavily. Now I have launched a Databricks over here, that's completely fine. Directly log into a Databricks. Now I'll just go to Azure, and here inside a search bar, or maybe over here create a resources, I can try to click, and maybe I can try to search for a Databricks. So data Databricks, I can try to search for a Databricks. A lot of services we are going to use, so let's get started with a Databricks. So I can try to go ahead and then I can try to search with a Databricks, and you will be able to find out something called as Azure Databricks. You can search over here directly, so Azure, Azure Databricks. You can try to search directly. That's completely fine. Now, as of now, everything will be blank, right? As you can see, so everything will be blank. Now you can try to click on create. So it will start creating a Databricks resources for you. So here, resource group is looking for. So shall we go and create, guys? Are you ready? Those who is having an account, those who is not having an account, just look into this lecture, and after this lecture, you can go ahead and create it within 2 minutes. It is just going to take 2 minutes of time. So whatever configuration I'm telling you, just have to follow that configuration, nothing more than that. Yes, shall we go ahead and create, guys? Okay, so let's go ahead and create this one. And like I said, those who is not having a account, don't worry, log in, try to create an account, and then in a later stage try to create it. Anyhow, I'm not going to use Azure from tomorrow. It will take some time, maybe a couple of weeks it is going to take, but obviously I'm going to use it at one fine day, so I'm going to use it. Okay, so here I'm using a pay as you go account. If you have a free account, you will be able to see a free over here where I'm able to see pay as you go with your account ID, right? With your long like a character plus numerical value account ID, you will be able to see. So you just have to select that one. You have to create a resource group is nothing but we are just trying to create one labeling. So and with that resource group, so we are going to attach everything, so like whether it's our compute, whether it's our servers, whether it's our databases, each and everything going forward. So here I can maybe try to go and create a resource group. So here Azure Databricks, EXPRIMENT, experiment resource group. Any name you can try to give, right? You can try to give, it will rectify. So this is the resource group I can try to create. Now workplace name. So what should be the Databricks workplace name in general? So here I can try to give maybe Sudhanshu, SUDH, Sudhanshu underscore data bricks underscore workspace, something like that I can try to give. Now reason, so always try to select a reason which is nearest to you, so nearest to your reason. So I'm in India, so I can try to select Central India. So if you are from a different location, so please try to select a nearest one so that your latency is going to be less. So you can try to select your region, means it is going to create those resources and servers in that particular region. Now, here we have pricing tier wise three options. So we have a premium role based access control, trial 14 days free DBU Databricks. DBU means Databricks unit, by the way, DBUs, Databricks units. Then a standard Apache Spark secure with Microsoft Intra ID. So I'm looking for like a trial. I can go ahead with trial. It's completely fine, right? If I just would like to like a try, and that too with a free, otherwise premium, it's completely fine. Now I can try to click on next, which is a networking. So I can go from here, leave it as it is, no need to do anything. Then I can click on encryption, again, no need to do anything. Click on security, again, don't have to worry about anything. Click on tag, no need to worry about anything. Create and review. So it will start validating your configuration. And like I said, it's just a 2 minute of job, right? So validation successful, as you can see, right? Validation is successful. Click on create. Shall we go and create, guys? So click on create. Simple. Okay. It is going to take some time. So maybe in general it takes like a 2-3 minute of time, I would say. So I'll wait. In between, if you have any kind of a question, so please go ahead and ask question. I don't have a Azure account. That's completely fine. Please go and create one. You can create a free account. You can create even a student account. So deployment is still in progress. Don't worry, we are not going to use Azure account from tomorrow. So you have time. You have a lot of time. But yeah, at like one day we are going to use it. Done, everyone? So for me, deployment is in progress going on as of now. Pradeep, create. I don't have a. Yes, sir. Got it. Pradeep, create new resource group. Yeah, you can just click on new resource and then you can create it. We are learning from Azure account, but we can apply for a jobs for a D, AWS and Google, right? I'll show you couple of operation in AWS and Google as well. But for a like a big data guy, so yeah, generally people are using Azure most of the time. But I'm going to show you a couple of services even in AWS related to a big data and even in Google account both. What is ETL tool? It's basically extract, transform, load, and there are multiple services which comes in between. So you try to connect the services and then perform a complete task. Means extraction of the data, transformation of the data, and loading of the data. That is something called as ETL. So there is a tool called as Informatica. There is a tool called as Talent, which is available in a market. But yeah, so even inside the Azure data factory you will be able to create it. Even inside the SD inside you can try to create it. Even inside a Databricks you can write a code where you can try to build the entire ETL pipeline. Depends upon like your interest and flavor. Still deployment is in progress. Okay, we'll wait. Sometimes it takes even a 10 minute of time. So can I select the free DBU? Yeah, go ahead with the free DBU, but it is going to give you 14 days of trial. So you have to like create another account if you're looking for a free after that. Means you have to use another ID, by the way. This is something like uh, it takes some time to create. Um, just wait. We don't have any other option. Okay, now it's done. So go to resource, and at any point of a time, you can even come to your home tab, and you will be able to find out your resource group. You will be able to find out your Azure Databricks. So here, click, and this is a resource. This is the Sudhanshu Databricks workspace which I had created. Now here, you will be able to see an option called as Launch Workspace. Simple, Launch Workspace. So here you can go and you can launch the workspace, and uh, it is just trying to do a sign in inside my Azure Databricks. Okay. And I believe a similar kind of interface you all are able to see. But if you will look into the workspace, it is basically Sudhanshu Databricks workspace. As you can see the name, it's basically a Sudhanshu Databricks workspace, right? So Central India. So what is Databricks and Data Factory? So I think this is what I'm trying to teach, right, Navneet? This is what I will be teaching you, that what you can do inside a data factory and what you will be doing inside a Databricks. Basically, it's a data factory is more like a complete platform. So where you can just by using a drag and drop and with the minimalistic effort, you will be able to create even a complex ETL pipeline, and you can try to schedule the job, monitor it, lot of things you can even perform. You will be able to perform a data transformation inside a data factory itself, and similarly on a Databricks you can do it. And both are basically a cloud based. So yes, a similar kind of a interface, guys. The interface which I have shown you here, so this is the interface which I have shown you just now. Similar kind of interface you will be able to find out here, but this interface is running on Azure Databricks and this is running on cloud Databricks. That's a difference, right? That's a difference. So this is running on a Databricks own serverless cloud. Serverless means a shared one basically. So this is running on a shared cloud space where you are not like paying anything. So again, they have a paid plan as well, and this is running on a Azure Databricks. How many of you are able to create it, guys? Azure Databricks. How many of you are able to launch it? Okay. So deployment is in Pradeep is saying deployment is in progress. Fine. Okay. Not an issue. Now here, so you can come to a compute this time, right? You can come to a compute this time. So when you will be able to launch a Databricks. So in case of this one, it is using a compute. So basically, it is using a serverless compute. It is giving you this serverless compute. You are not paying for that, right? And you can even attach the external one. Now here, so you can try to click on create compute, and it is going to give you a complete different interface. And here, so you will be able to set up your master slave kind of a cluster. So recently we talked about a master slave, right? So like in my previous class and even today, so I was talking about a master slave architecture, right, guys? Everyone? Yep. Master slave architecture we were talking about. Yeah. So here, right? So here, let's try to create basically a shared computer. It is going to charge me, by the way. Okay, fine. I'll just like still I'll create it. So I'll have to pay for it. Okay, unrestricted, then access mode, single user, fine. And here you have an option, as you can see. So you have basically a multi-node cluster and a single node cluster. I believe this is the architecture that we talked about. So we talked about a multi-node architecture where there will be one name node and then rest of the node will be like a worker node, basically, right? So you can try to select a multi-node. You can try to create a multi-node in a easiest possible way, just with the help of couple of clicks. This is how easy it is actually. And then you can try to configure it, single user, multi-user, like you would like to give an access to the entire team, that's completely fine. And database runtime version, so here I can try to select maybe a latest one, so LTS, which is a stable one, so 25 word. Apart from that, so they are giving you machine learning libraries or setup as well. So database runtime machine learning, so we can go ahead with the standard one, fine. Now here, if you are going to come, so if I have selected multi-node, if I have selected only multi-node, only in that case it is going to give you an option to select a minimum worker node and a maximum worker node. So minimum is going to be 2 at minimum. I believe they will not allow you at the time of submission, or minimum is 1, fine. Driver type, so same as a worker node. So driver type is nothing but your name node, right? So from here you can select any kind of a configuration, and even if you are going to enable a GPU in your region, again, so some GPUs, some configuration will not be available in some of the region. So if you are planning to configure even a GPU, everything is available to you, but with a cost, obviously, right? But with the cost, you will like you will have to like create it. You'll have to basically create it. And minimum worker node, maximum worker node, so I will not select for the multi node cluster. I'll go ahead with the single node cluster, right? Single node means in one single computer there will be a name node service, there will be a worker node service, everything in the single node, just like your laptop is basically a single node, right? So if you're running something inside your like a laptop, it's technically a single node basically. Now, so here it is showing me 2 dbu per hour. I can just unselect it. It is going to reduce my dbu. So technically I'm reducing my cost basically over here. So by default, I don't want a Python acceleration. That's completely fine. I can wait for my query to execute. I don't have to accelerate it. Now terminate. So all the configuration is very like a basic from here. So you can try to select like a runtime. So runtime is completely fine. Now node type means a machine that you are looking for. So I am not looking for a very heavy machine. D4 V5, that's fine. Let me check if there is some two core machine which is available, two core, so that it is not going to cost me much. Two core, two core. No, minimum is four core. Okay, fine. 16 GB. So anything lesser than that, there is 14 GB V2 4 core. Now, so my DBU has reduced. Databricks unit per hour has reduced to 0.75. So 1 to 0.75. So now like even cost has reduced little bit. Terminate after 30 minutes of inactivity. So if I'm not working on this cluster for 30 minutes because it's a paper use, terminate it after 30 minutes. Now, advanced option, don't have to worry about any advanced option. It's completely fine. Now, click on create compute, and it will take some time. And it is going to create an entire compute for you. And then I'll show you some amazing things. Just wait for a couple of minutes, guys. So I'm just trying to create a system, guys, basically. So this creating compute means I'm creating my system. I'm trying to create my server so that I will be able to run any kind of a processes on that server. Basically, I'm trying to create a laptop in a cloud platform. Anyone who's doing it, guys? Pradeep, what happened? What happened to you? So are you able to spin up the cluster? Data node. Yes. Okay. Then great. Anyone else who is doing it? So again, configuration wise, setup wise, believe me, it's not at all a big deal. So when I have started my big data career in 2016, I believe, yeah, 2016. So at that point of a time, the entire infrastructure of a big data was in a very very early stage, and at that point of a time, Cloudera was available, Hortonworks was available. Uh, and again, so we had to do a setup, we have to set up the manual cluster, we have to monitor it, we have to maintain it, then we have to write a lot of code just for that management, plus manually we used to create a complete ETL pipeline end to end. Even at that point of a time, there was a tool called as Informatica and Talent which was available in 2016, but the problem was that like uh, if you're running some of the heavy processes, uh, it's just like a wrapper, so you can't you don't have a much control over the process optimization, right? And obviously for our like clients, so we had to do a lot of optimization. So keeping that in a mind, we have built the entire ETL for Mercedes Benz Japan in house. We have written each and every piece of a code to maintain their aftermarket supply chain. So that was fun. But yeah, so same thing if I have to do it today. So maybe I will be able to do it in a easiest possible way just by using this cloud infrastructure. Even at that point of a time, this cloud infrastructure was not that great. So we had to do it everything on our own. Which is best, Azure cloud or standalone Databricks? See, a standalone Databricks will be having some limitation. At the end of the day, everything comes to a resources. See, it's not about the process, it's not about writing a code, right? So big data is not about like writing a code. You have written a beautiful code, so it will be able to work in i5 system itself. No, it's not like that. It's always about a compute. It's always about the service integration. So obviously, Databricks and Azure is going to complement each other at the end of the day. Yeah, so everything takes time. So it is still creating my resources, guys. So that I'm just waiting for it so that I will be able to show you a Spark UI driver log, a Spark UI component. Here, you can run any Spark job and you will be able to monitor it, that what is going inside a particular job, even on a micro level. So you will be able to optimize all of those jobs. That is also possible. So just make sure, not maybe tomorrow or like a next week, but yeah. So in a couple of weeks, try to get your Azure account ready. It's just like a sign up. If you have done the sign up and if you have added your card, it's fine. Then done. You can try to enjoy a free tier inside the Azure. Okay, so my cluster is ready now, and I can try to go to my new notebook, and I can try to connect my new notebook with Sudhanshu Kumar cluster, as you can see. So this is the cluster which I have created. This is the basically a compute which I have created. Now, whatever compute will happen, it is going to happen on my Azure cloud platform. So this is the compute which I have created, and even you can try to check. So what is a resource that I'm using? So basically, I'm using a 14 GB of memory, a RAM, and a 4 core I'm trying to use over here, and this is the like a version of the compute which I'm able to access in this particular place. Now if I'll go inside the compute, right, if I'll go inside the compute, I can terminate it, and obviously I have to terminate it. And if I'm not going to terminate it, so I have already made a setting that in 30 minutes of inactivity it is going to like a terminated. So here you will be able to see Spark UI. So whenever we are going to run a Spark job, even a single line of a code we are going to submit, everything you will be able to monitor from this particular UI, whether it's a SQL data frame based job you are going to run, whether it's a streaming job that you are going to run, everything and anything you will be able to monitor from this Spark UI. As of now, it's completely blank because I have not executed any job in this particular cluster. So it is a new one, right? It's a new one. Then so basically like here you will be able to see all the activities, not just this. So you will be able to see all the activities in this particular place. And yeah, so we are going to use this one on a regular basis to observe so how my Spark job is performing, and if it is taking time, so how much time it is trying to take, if we have to optimize it, so how I will be able to optimize everything. I can try to observe, and if my job is going to fail, I will be able to monitor even from here, each and everything. Fine guys, making sense? Yep. So are we going to learn a Spark from the basic, right? Yeah, from complete basic. So from tomorrow onwards, I'm going to start a Spark from the very basic, ABCD of Spark. Now, so let's suppose I have launched it. So don't forget to terminate this one. So it's better. You can go to Azure itself right here. And then you can try to click on see all. And then you can try to maybe select one. And please try to delete your resources as you have already added your card, because without adding a card, Azure will not allow you to create it. So just to avoid that mistake, because I have seen people so who are using our resources and they just keep it as it is, and then they say that you haven't told me to delete the resources. So keeping that, and that has happened in multiple classes. So that's the reason. So in a very first class itself, and that too in a zeroth class, when I give an introduction, so I try to show them that come over here, delete everything. Everything means everything. Now if I'm going to hit this URL after some time, so it should not work. After some time it is still deleting my resource, right? So Databricks Azure experimental and Databricks workspace, it is going to delete, and once it will be deleted, right? Once it will be deleted, so deleting status is basically deleting as of now. So fine. Once it will be deleted, I will not be able to access it, and Azure is not going to charge anything extra for me. But yes, if you are like keeping it active, then please don't come back to me and say that you haven't told me. I told you in our very first class, right? So that is something which I used to follow. Making sense to all of us, guys? Yeah. Like I said, Azure account is not required as of now. So we'll be using this Databricks free version. Standalone Databricks we are going to use from tomorrow onwards to learn our Spark, or to start our Spark journey, and then eventually we'll try to move to the Databricks. Right? Fine. Any fake credit card can use. I don't know. I have never used it because they will be asking for an OTP. So I don't know if you're able to submit the OTP and verify it. But yeah, I haven't done that. So sorry, I'm like I can't answer to this question in a proper way. Okay, fine, guys. So I'm done for today, and let's conclude the session. And from tomorrow onwards, we are going to focus just on a practicality, because that is something people are going to ask you. And out of that, you will be able to build a project. And in between, obviously, there will be a lot of theory which will come. But yeah, that is going to be in between 5 to 10 minutes of theory and then complete practical. So, with that, thank you so much, everyone, for joining a session. Those who have not joined, so video will be available inside your dashboard, so at any point of a time you can go and you can watch this entire recording and whatever resources is required. So I'll be sharing all of these resources with all of you inside the dashboard itself. With that, thank you so much, everyone. Take care, and see you in my next session, which is going to happen tomorrow. Thank you so much, everyone.